Hello students, I hope all you are fine. Today we will start exercise 2.3 and what we will do today in this exercise, we will do this remainder theorem. So first of all I want to tell you what is this remainder theorem. Let Px be any polynomial of degree greater than or equal to 1 and let A be any real number. If P of x is divided by the linear polynomial x minus a, then the remainder is P of a. So what is this, students? P of x is a polynomial and we will divide this polynomial by gx. This is a polynomial px and this polynomial gx is divisor. Then how can we find out this remainder? We just equate this gx equals to 0. So what is our gx? X minus a. This is equals to 0. This implies x equals to a. So we find P of a and that value will be the remainder of Px. Is it clear, students? Okay. Now we will start our question. Our first question, in this question we have to find out the remainder. There are two methods for finding the remainder. First, simply by division method you can find out, but I will explain that method later. Second method, by remainder theorem you can find out the remainder. So our given polynomial is x cube plus 3x square plus 3x plus 1. And now we have to divide this by gx, that is equal to x plus 1. Now we have to find out remainder on dividing this polynomial by this. So first of all, what I told you, students, we equate this gx equals to 0. That means x plus 1 equals to 0. This implies x equals to minus 1. Now students, we will find out P of minus 1. As we did yesterday, at the place of x, you will put minus 1. Minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. Minus 1 cube, that will be minus 1. You know very well, if you are taking the odd power of negative number, you will get the answer negative. 3 into minus 1 square, that is 3 into 1. 3 into minus 1, minus 3 and plus 1. Minus 1 plus 3 minus 3 plus 1. As you can see, students, we are getting equals to 0. So our remainder is 0. This is the final answer. X equals to x minus 1 by 2. Repeat the same process, gx equals to 0. This implies x minus 1 by 2 equals to 0. X equals to 1 by 2. So what you will find out? P of 1 by 2. 1 by 2 cube plus 3 into 1 by 2 square plus 3 into 1 by 2 plus 1. 1 by 2 cube, that will be equal to 1 by 8 plus 3 into 1 by 4 plus 3 into 1 by 2 plus 1. Now what will you do, students? Write these terms. 3 into 1 by 4, 3 by 4, 3 into 1 by 2, 3 by 2 and then plus 1. Take LCM, 8 will be the LCM, then here 1 will come, then 4 2s are 2, 3s are 6, 2 4s are 4 3s are 12, and then 1 8s are 8. Add all these terms. 8 plus 12, 20, 20 plus 6, 26, and then 1, 27 by 8. So this will be the remainder by dividing this polynomial with this another polynomial. Have you got it, students? You can take the screenshot of this one. Now I am doing third part. Polynomial is same again. Given polynomial px equals to x cube plus 3x squared plus 3x plus 1, and here gx equals to x. Here you can see, students, there are no constant terms, but no need to worry. Take this gx equals to 0. This means x equals to 0. So what you will put, beta? P into 0. P 0 we will find out 0 cube plus 3 into 0 square plus 3 into 0 plus 1. So what we are getting from here? 0 plus 0 plus 0 plus 1. So our remainder is 1 when we dividing this polynomial by x. In our fourth part, this polynomial, we will divide this polynomial by x plus pi. Put this gx equals to 0, x plus pi equals to 0. This implies x equals to minus pi. You need not to find the value of pi. You will just find p of minus pi. At the place of x, put minus pi cube plus 3 into minus pi square plus 3 into minus pi plus 1. Minus pi cube, it will be of minus pi cube plus 3 into pi square will come plus 3 minus pi. That means plus minus 3 pi plus 1. This will be your remainder by dividing this polynomial by x plus pi. You will not put the value of pi, you will get the remainder in terms of pi. Now coming fifth part. In this fifth part, what you will find out? You will divide this polynomial px by gx equals to 5 plus 2x. Take this 5 plus 2x equals to 0. 2x will be equal to minus 5. Here 5 is of plus and it will go that side and convert into minus 5. X equals to minus 5 upon 2. Here 2 is in multiplication, so it will go in division. So what you will find out, students? P of minus 5 by 2. Put the value minus 5 upon 2 cube plus 3 into minus 5 upon 2 square plus 3 into minus 5 upon 2 plus 1. Minus 5 cube, you will get minus 125, and 2 cube, that is 8, plus 3 into 25 upon 4. We are taking the square of 5 and 2. Plus 3 minus 5. Plus minus 15 by 2. And it will come 1. So these terms plus 75 by 4, as we know that 25 3s are 75, minus 15 by 2 plus 1. Take LCM. 8 minus 125 plus 4 2s are 8 and 75 2s are 150 minus 2 4s are and 15 4s are 60, and here nothing is in the denominator. You will take 1 8s are, so you are getting quotient 8 and 8 ones are 8. Combine all plus terms and all minus terms. Firstly, I am combining these two terms, minus 125 and minus 60. So what I am getting? Minus 185. After that, combine these two plus terms. These are 158 divided by 8. Here you can see, students, we are having value minus 185 and one value of plus 158. You will subtract the value from bigger one. 15 minus 8, you will get 7. 7 minus 5, 2. And this 27 will be of minus. Why beta? Because this bigger term is of minus. So, minus 27 by 8 is our final answer. Question second, here the given polynomial px equals to x cube minus ax square plus 6x minus a, and we have to divide this polynomial by gx, that is equal to x minus a. The same thing you will do here, students. Take this gx equals to 0. This implies x minus a equals to 0. So you are getting x equals to a. So what you will find out, students, by remainder theorem, p of a, we will find out a cube minus a into a square plus 6a minus a. A cube minus a into a square. While multiplying the variables, if you are having the same base, then powers will be added. So here you will get a cube plus 6a minus a. This a cube will be cancelled by this because one is of plus and one is of minus. Plus 6a minus a, you will get 5a, and this is your remainder. So students, you can do this question by division method also, and I am doing the last one question by division method. It's your choice. You want to do by remainder theorem or by division method. But if in exam, if it is given that you have to find the remainder using remainder theorem, then you have to use remainder theorem. Now, coming question third. Check whether 7 plus 3x is a factor of 3x cube plus 7x. What we have to tell in this question, student? We have to tell that this is a factor of this polynomial or not. First of all, we will divide this polynomial by this polynomial. Yes. If we are getting remainder equals to 0, then we will say this is a factor of given polynomial. And if remainder is not equals to 0, then we will say this is not a factor. So both methods you can apply here. I am doing the division method. So I am taking this inside 3x cube plus 7x, and here I am writing this 3x plus 7. So first of all, compare this coefficient of x cube. This is 3 and this is also 3. So we need not to take any constant. So again this is x and this is x cube. We have to make this power equals to 3. Means we will multiply this term by x square. So by multiplying this with x square, what you will get, students? You can see 3, if nothing is here, that means I am taking 1, 3 ones are 3, x into x square, x cube will come. So 3x cube plus 7 multiply with x square. What you are getting, students? 7x square. Now next step is change the symbols. Here is plus, it will come off minus. In the same way, this is of plus, it will come off minus. cube is of plus and this of minus, so it will be cancelled. Here this is minus 7x square and take this term here. Now I need this coefficient of x square minus 7, but what is here? This 3. So we have to cancel this 3 and we need to take 7 here. So what I will do here, I will divide it with 3 and multiply with minus 7. And x raised to power 2 is here, so I will take minus 7 by 3x so that I can get minus 7x square after multiplication. So I am taking this minus 7 by 3x. So from here I am getting minus 7x square. After that plus minus minus 7 7 ja 49 by 3x. Then change the symbols again, it will be cancelled, and here 7x plus 49 by 3x. Take LCM. 7x plus 49 by 3x, 3 will be LCM, and 21x plus 49x, it will be of 9 1 10 or 4 2 6 1 7, 70x by 3. So you can write it 70x by 3. Here the coefficient is 3 and I need 70 by 3. So I will multiply it with 70 by 9 only. So what I am getting from here, 70 by 3x plus 7 into 70, 490 by 9. Now change the symbols, it will be cancelled and it will come as remainder. From here you can see the students that this is not equals to 0, means remainder is not equals to 0. So you will say 7 plus 3x is not a factor of px. Now I will again tell you the another method of finding the remainder of this polynomial by dividing this given polynomial. You can use this one method, otherwise you will use remainder theorem for finding the remainder. So students, do the same thing. This is gx, that is 7 plus 3x, and keep this gx equals to 0. This implies 7 plus 3x equals to 0, and you are getting 3x equals to minus 7, x equals to minus 7 upon 3. So you will find p of minus 7 upon 3. Take this polynomial as px. 3 into minus 7 upon 3 cube plus 7 into minus 7 upon 3. 3 into minus 7 cube, that will be equal to 343 divided by 27. Minus 49 by 3, and you will cut this by 9. Minus 343 upon 9 minus 49 by 3. You can cancel the common factor here. That will be, you cannot cancel, you have to take the LCM, that is 9 minus 343 plus 3 3s are, and you have to multiply this 49 by 3. 3 9s are 27, 3 4s are 12, 12 or 2 147. And now both terms are of minus, so you have to add these two terms. 7 3 10, 4 4 8 1 9, 3 1 4 1, 3 or 1 4, and it will be of minus, divide by 9, the same remainder you are getting which you have got in that one method. So here is also this remainder not equals to 0. So what you will say, students, you will say 7 plus 3x is not a